Welcome to LNP Renewable System Integrator. Today we are going to see some of the solar photovoltaic system basics. Okay, so in this session we can classify it into three parts. So in the part one, let us try to discuss. So in the part one, we are going to discuss the following things: how the solar cells are manufactured, and what are the steps in the manufacturing process. Okay, what are the type of panels based on the silicon wafers used, and what are the type of panels based on number of cells. So now let us try to know how the solar cells are manufactured. The basic thing for the solar cell manufacturing is the silica sand. Okay, it is processed with the help of this Zokravarsky process. Okay, it is a method of crystal growth. Okay, which is used to obtain the single crystal of semiconductors. So normally silicons, germanium, gallium, all these semiconductors. Okay, we are extracting through this process only. Okay, Zokravarsky process. So he is a scientist who discovered it. So that's why it is called through his name Zokravarsky process. Okay, so the silicon sand, it is being processed with the help of this method. It is converted into a crystalline silicon. Okay, then these crystalline silicons are got melted, okay, and formed into a monocrystalline ingots. Okay, then through the slicing and cutting process, okay, we are taking the silicon wafers. From the silicon wafers we are preparing this silicon cells. Okay, and in some cases we have a doubt, this is a monocrystalline ingot, you're telling how will be the polycrystalline. See, while preparing the silicon wafers, now there might be lot of wastage. Okay, from that wastage they are, okay, they will be melted from maybe different monocrystalline ingots will be used. Silicon vapors we will extract, but at the end of this process now so many waste will come. Those wastes are collected together and they are formed into a polycrystalline ingot. From that one, polycrystalline vapors are prepared, and the solar cells of the polycrystalline type are being prepared. So this is how, see here, the pure form is the monocrystalline form, which is directly extracted from the silicon sand. We are getting a crystalline silicon. From the silicon, through a heating process, we are melting them and we are forming a monocrystalline ingots, and from that ingots we are taking this silicon vapors. From that we are preparing the solar cell. Whereas in case of polycrystalline, whenever we are doing a slicing process, we are preparing the silicon vapors, there will be so many wastes. All these different monocrystalline ingot wastes are collected together and they are formed into a polycrystalline ingot. From the polycrystalline ingot we are preparing a polycrystalline silicon vapor and solar cells. Okay, okay, basic terms we should know. What is a solar cell? Okay, what is a solar module, and what is a solar panel, and what is a solar array? We should know. See here, solar cell is nothing but a photovoltaic device. Okay, it will generate the electricity when it is exposed to sunlight. So that's why it is called as a solar cell. Okay, what is a solar module? When smallest, okay, when smallest the solar cells are interconnected together, they form a module. It can be a monocrystalline module or a polycrystalline module. Okay, and what is a solar panel? When this group of modules, okay, they are fastened together, pre-assembled and interconnected, and they are served to okay, they are designed to serve a individual purpose. They, when we are able to install them as a single unit, then we used to refer it as a solar panel. And what is a solar array? Solar array is nothing but, say for example, one panel maybe we prepared or we bought, which is of 300 watts. Okay, now we want to take around 12,200 watts. Then we need to, what we need to do, we need to make all these solar panel, 300 watt solar panel, series together, maybe around 4 panels. Okay, so 4 into 3, 1200. Okay, so 1200 watts panel power we want to take. So what we can do, we need to connect all these solar panels together, so that forms a solar array. Okay, and also one more important term we need to know, what is EVA? It is ethyl vinyl acetate. What is the purpose of this? It is designed, okay, it is a polymer, okay, which is highly transparent plastic. You know, while preparing a panel, okay, we need to cover the cells okay, inside a plastic. So we are using this plastic, ethyl vinyl acetate plastic we are using, which is a transparent plastic, so which helps to hold the encapsulate the cells properly. Okay, and most important feature of it is it should be extremely durable and it should tolerate the extreme temperature and the humidities. Okay, it plays an important role, okay, in the long term performance of the solar ingots. okay, preventing them from the moisture and the dirt ingresses. So as we told earlier, so this is see here how normal solar cell is working. One of the sample, it is providing the DC electricity. So this is how the solar cells looks like, and when these are arranged together, they form a module. And to serve our particular purpose, we are making interconnect. We are connecting, okay, all these models together. They form a solar array. See here, individual solar panels. Inside this, there will be a tinted coppers will be there inside this. Along with the wafers, inside the wafer we are making this tinned copper lines, and also we are providing the silver oxide lines also. So that's how a single solar cell is getting prepared. And see here, we are interconnecting all these things internally, the solar cells. So now we are making a module, and see here we are taking a positive line outside, and we are taking a negative line outside. See, we had inside this uh, junction box on the back side, okay, we have a bypass diodes and a blocking diodes. So what is the use of this bypass diode? See here, it should only the current flow should be from positive to negative. Okay, that is the purpose of these diodes. And also blocking diode, what it will do, when current flows reversely, it will protect the solar cells from the damages. So this is how normal, the basic, okay, the basic solar module or solar cell contains. Okay, and now we are going to discuss what are the different types. Okay, there are so many types. Okay, p type solar cells, n type solar cells, heterogeneous type solar cells, TOPCon type. So what is the difference in the n type solar cells? The negatively charged silicon is doped with the phosphorus. Okay, what are the examples of n type? So nowadays we have a higher efficiency panels like LG, Panasonic, Sunflower, REC. So all these are efficient panels. Okay, in this one we used n type silicon wafers. Okay, so at the starting stage of this solar industry, p type solar cells are being used. So in the p type, the positively charged silicon is doped with the boron. This is one of the oldest method. At the starting phases it was used. It was little costly method. Efficiency was little around 18%, 17%, like that only. But now the efficiency, because of the invention of this n type solar cells, okay, the efficiency has got improved from 19 to 20, 21, 22, like that. The efficiency got improved. Okay, and next type is also one of the example, that is heterogeneous type. In this one, okay, generally we use the base of the high purity n type crystalline silicon with additional thin layer of amorphous silicons on either sides of the cells. Okay, so we have images, so we will show you so that you will have a little more clarity on the different types of these solar cells. Okay, and also one more new technology which is arrived, that is TOPCon solar type technology. TOPCon stands for tunnel oxide passivate contact. Okay, this cell architecture essentially helps to reduce what is known as a recombination losses in the cells, which in turn boosts the cell efficiency. Okay, and heterogeneous type, one of the best example is the REC alpha series. It's the best example of heterogeneous type. So as we told earlier, there are different type of panels, okay, based on the silicon wafers used. Okay, as we told earlier, there is a polycrystalline, and there is a monocrystalline, and there is a one more type, cast monocrystalline also. Okay, and what are the different types of panels based on number of solar cells? See here, in the first model we have a 60 monocells, so that's why it is referred as a 60 monocell type. In the second one, see here, we have 120 half cell cut monocells, and in the third type we have a 60, okay, IBC cells or 96 IBC cells. See, this is an example of shingled cells. Okay, mostly this is used in heating industry. Okay, and this is 60 multi-bus bar cells. So based on the number of solar cells present inside that particular panel, we are classifying. So these are some of the examples. Thank you so much. Please subscribe and press the bell icon to know more and learn more. Okay, feel free to contact us. So we had provided the contact details in it. Okay, if you want to do projects with us, you can contact us. We are providing design, installation, testing and commissioning supports for the solar on-grid, off-grid and hybrid applications, and we are also providing the basic training for electrical vehicles. So if you want to do any sort of workshops or trainings, short-term trainings in your colleges, institutions, You can contact us. We had provided the contact details, and also we are providing design, installation, testing and commissioning support for automation, industrial automation, home automation, and the building automation. If you want to know the basics of all these systems, we are also providing training in that. You can contact us. We have provided the contact details in it. Thank you so much. So let's try to see few more things in the next part. Thank you.